Welcome, everybody. Thank you for joining us this evening. My name is Eric Espy. I'm the Recruitment and Student Services Manager here at Carnegie Mellon University Online. The plan here is going to be going through some of the program basics right at the start of this presentation, just so for some of you that might not have a good feel for the program yet, we want to make sure you get the basic schematics of the program itself. And then we'll get into the good stuff. We'll go through some questions and gain a really great perspective from Cem's experience in the program, which is I'm sure what you all are really looking for as far as the meat and potatoes of this. And then at the end, we'll just wrap up with a Q&A. I know, firstly, thank you all for bringing your questions into the forum when you signed up. We're excited to get to those questions at the very end. And then we'll have time where you all can chat questions as well. So before we jump in to the actual AIEF, or the AI Engineering Fundamentals Graduate Certificate, we did want to let you all know, in case you didn't understand, that CMU Online itself is a combination of several different online graduate certificate programs. You can see here that we cover subjects like Foundations of Data Science, Generative AI and Large Language Models, Managing AI Systems, this program, Engineering Fundamentals, Digital Twins, 3D Biofabrication. So as you can see, an assortment of different subject areas. But again, those are the programs that we're primarily representing at this time. But moving forward into really what sets us apart, as you all know, this is a graduate level certificate. There's a lot of certificates out there right now. What really sets us apart, what we really stand true to, is firstly, this is graduate level credit-bearing coursework that you are taking. That's very important for many of the students, prospective students that my team is working with, that, this is not just some sort of badge that you gain at the end and you can put it on your LinkedIn. These are full-fledged CMU courses that you're going to be getting afterwards with an official transcript. So our students really love that. Even though this is a graduate certificate that is online, you're still getting the same rigor as what you would experience here on campus with this credit-bearing coursework. If you look below, paired with that is you're also being taught by full-time CMU faculty. So the instructors here are also teaching here on campus. You're not getting somebody from the outside of the CMU umbrella that's teaching these courses. Our students really love the fact that they're getting taught by a full-fledged CMU faculty throughout this process here. And if we go to the top right box, weekly online sessions or classes have been absolutely essential and a great positive point of feedback for many of our students taking this particular program. Unlike a lot of certificates where they're mostly async or self-paced the entire way through, you actually are going to have weekly live sessions that you can attend. And that way you get that live interaction piece with not only your classmates, but also the full-time CMU faculty and instructors that are helping out with the program itself. And then lastly, this is designed for working professionals. So the majority of our students that are taking this graduate certificate are balancing full-time work schedules, other commitments, while also taking this. And so, our students really appreciate the fact that they don't have to drop, critical parts of their lives to be able to take this and complete this graduate certificate. And I don't want to go too far in the depths here, but we do want to give you a program overview of the certificate itself. Mainly who this is for, typically who we're seeing are engineers, really focused on leveraging AI, machine learning, deep learning tactics to solve real-world engineering problems. We also see recent graduates in engineering or software engineering majors that are looking to take this to gain a one-up or a level up as they're looking at the job market or looking to grow within their own current roles. And then the areas of which you're going to be learning, we're going to be looking at the fundamental methods and algorithms of core modern machine learning, theoretical foundations and techniques of supervised, unsupervised learning, the basics of neural networks. So that's been popular for some of our students taking this program, and then being able to apply deep learning to several different disciplines of engineering. So those have been the main takeaways of what you're going to be learning in this particular graduate certificate program. And this particular certificate is very simple. So just 2 courses over the course of 2 semesters. The first course that you're going to be taking, so we're just showcasing this as if you were going to be starting this spring for the next, which is going to be the next intake. The first course is Machine Learning and AI for Engineers. And then the next semester that you'll be able to finish and take the last class part of this, that's part of this graduate certificate, is going to be the introduction to deep learning. So both of those are 2 units or 12 units. And again, each of those are their own semester. All right. All right, great. So we've made it to the introductions. Cem, thanks for hanging out here in the bullpen for us before this introduction. Thank you so much for joining us tonight.
It's my pleasure.
If you'd like, it'd be great to hear just a bit of your background, what really brought you to this certificate, and what was your experience like? Yeah.
Sure. Hi, everyone. Thanks for joining this evening. I'm an electrical engineer by training, and I've been in the field of telecommunications, networking, internet world for the entirety of my career. And you can tell I'm sort of like the late stage professional, as they say, not early career professional. And so you asked me what brought me here. Well, as I was a graduate student, artificial intelligence was a thing, like this is like late 80s, early 90s. And it never took off because I remember taking an artificial intelligence class. They taught us some weird programming languages that I never really sort of take any liking to it. And it didn't look like it was anything then other than just programming. There was no difference. So there has been all these false starts, and I never paid a whole lot of attention to artificial intelligence. But let's say over the past decade or so, it's becoming more prominent. People are doing real things with it. Now it's not like a hype anymore, or it's like it wasn't like a wishful thinking. So that's why I thought it was about time that I sort of pay a little bit more attention to it and try to see if I can understand what it is about and see if I can actually use it in my professional life or even in my personal life. There are a lot of things that you can do with it once you sort of understand what's under the hood. So that's what brought me to here. I tried to watch a bunch of YouTube videos and like other online classes, but needed something curated and that will touch different portions of the learning experience because you can take, some classes, it will instruct you, okay, type this, type that. Oh, look, you can, sort of classify that's a cat and then you feel good about it. But that doesn't really like get you there because there's some math behind it. There's some practical tools that you need to use. So just having a curated curriculum that just walks you through. And I didn't want to guess what I need to learn and what is not really relevant because you can spend and learn, a lot of time learning something that may not be useful at all at the end of the day, and then your time is wasted. So that's why I started in the last spring. This is my second semester, so I'm taking the Introduction to Deep Learning class now. Yeah, so that's about it.
Excellent. Yeah, thanks for sharing, Cem. You made a good point that we hear this all the time when we're talking to prospective students that there's too much information and too much when it comes to like learning opportunities of how to jump into AI. And again, to your point, we reassure this with the credit-bearing coursework. You're getting something curated, something that's structured, and it's going to be relevant to today's AI challenges. So I appreciate you sharing that. Yeah, thank you. And then let's go to the next slide. We had Karthick join a little bit later tonight, but Karthick, I'm not sure if you have a camera ready or if you want to jump in with just audio. We'd love to hear a little bit of your background too and your experience with the program.
Yeah, absolutely. Yeah, I joined a little late, but I can't get on a video right now. But I'll definitely love to talk about my background and why I took this course and how it's gone for me so far. I'm a mechanical engineer and I work primarily in the CAE space, so CFD, FEM tools, and I also work in the EDA spectrum at Cadence Design Systems. So the reason for me taking this course was kind of there was a lot of focus on AI, machine learning, neural networks in the recent years in the physics space, in the CAE space, in the design space. Frankly, I was not really sure what it meant. And for me, there was a little bit of reading I tried to do. before this course and tried to, go through some online, let's say, tutorials and videos. And I didn't think I was getting a hang of it. The reason why I took this course was two reasons. It was very structured. So I started off with like classical machine learning and then went to deep learning. And it gave me more an idea of the math behind it. And then you start learning to code and, then you start going into neural networks and, it was kind of like a ladder approach to getting there. And I found that very useful. Unlike when I was trying to look for what to do straight away, I would see like NLPs and I wouldn't understand what NLPs really meant and what to do with them. So that was my thing. The reason why I would say invested some, let's say, money and took a course like this, apart from something, that was free elsewhere, was I was more like I want to keep myself accountable. Because I know that, if I invested time and money, for example, let's say, I would actually be more stringent about, with myself about doing the weekly assignments and, getting stuff out by this thing and actually working on it rather than sometimes you would go to Coursera, take a course and then, spend a few weeks on it. And then, you would just drop it because, life goes on, right? Life keeps catching up with you, something at work, something at home or one of those things. So far I think for me whatever I wanted from this course I've gotten, and I think so far the reasons why I took it in the first place, I think so far they've been justified.
That's great. Thanks for sharing that. I agree with you. I couldn't tell you how many times I've started a Coursera course and I just kind of get, 2-3 hours in and then life happens. And then it goes into the archive.
Yeah.
So thanks for sharing that. That's great. And we noticed that you and Jem both went to NC State, which is really cool. So, what are the chances of that? And I guess great minds think alike. NC State, CMU, sounds like a good path to me.
Yeah, I didn't realize
Yeah,
that.
you're
Yeah.
probably bunched in your department. Yeah. When I was there, we were the national champions in basketball, and it hasn't happened since.
Yeah.
Hey,
Go,
who knows, who knows what might happen this year.
go,
Um,
go Wolfpack.
that's right. Yeah, that's great. Well, thank you. I appreciate your perspective there. And what we're gonna do now that we're about a quarter of the way through our time, we're going to jump into some specific questions. And these really are the curiosities that we typically get from prospective students and what they would like to hear from both of you. So, Jem, I don't know if you want to kick us off, but um, with this question, how did the program meet or differ from your expectations? I'd be curious to hear just your perspective on that.
Yeah, I mean, I'm going to sort of repeat some of the things that I've mentioned and or Karthik mentioned as well. The I wanted to go through a learning process where I actually learn the math behind it, because that's important. Unless you understand the theory behind it, then you would be just blindly applying things, and you want to be able to sort of get advantage of what you learn. So, and the other thing that's Karthik mentioned, which is the structure of it. So this class was really good, especially for people that are working as well. The structure is really good because you have the asymmetric mode of learning which is lots of the classes are all the classes are pre-recorded and they're like bite-sized, 10 minutes. But I could never watch something within 10 minutes and understand that. I would have to sort of go repeat, especially maybe there would be like a 30-second segment that you go over and review it until you understand that before you move on. So that part was really, really good. And it was like a real life class. Then, basically the first point where you actually miss the point, then the rest of the class is just wasted, right? So this asymmetric teaching is useful, at least for someone that learns like me. It was useful. And then once you finish those bite-sized lessons, then you go take a little quiz just to test to see if you actually really understood. So once you do that, then, and that's similar to what like an online class maybe, but then when you go actually to the real lecture, and the professor repeats most of the material, maybe highlighting some of the things that are more important, and then any questions that you may have, you may bring it up. That way, it just reinforces your learning process. And then at the same time, there's the weekly assignments, and then you try to do them on your own. TAs are available to help. So basically, all these dimensions just worked well, at least for me, to be able to sort of make optimal use of my time.
Yeah, that's great. Thanks for sharing that, Jem. I crave almost, I wish I had that model when I was in school, where it's almost like a flipped model where you're not just being lectured to and you're daydreaming half the time. And then the professor says basically, okay, this will be on the final. See you in 8 weeks, it's just not very effective. So it seems like this model just helps, you trial and error enough to be able to get comfortable with what you're learning and then being able to put the icing on the cake during that live session, which is great. Yeah, thanks for sharing that. Karthik, what about you? Anything, when it comes to the program meeting or differing from your expectations?
Yeah, I think meeting, what I would say is like what I mentioned before, right? It's a structured program. There is a tiered approach to how you progress. There is also accountability. The assignments are tough. They can get really tough. So you kind of have to be on top of what you're learning, and maybe even go outside the syllabus sometimes to if you really want to do well in the assignments, right? So that was what I expected. So I think the one thing I maybe did not expect, and I think I had to adapt kind of towards the end is, so I know Cem, for example, he's always in the classes, like he attends all the live sessions, and a few others do. I do have to take the whole thing remote, so I don't usually join the live sessions. I look at the Zoom recordings. Um, and I did find at some point in the course that there are periods of lull. So, for example, once you get used to a certain pattern of assignments, let's say, and lectures, you get used to it and you are getting more efficient. And all of a sudden, you'll see a sudden spike in the difficulty. And one week you're really scrambling to, you have no idea what's going on, and you're like, hey, you know what? I didn't expect this week to be so difficult. I started on Friday, and I just have 2 days to finish. So that does happen. And I think in some of it is probably because it's online. I think if it's an on-campus course, you have people that you're interacting with on an everyday basis. You're kind of more aware of, okay, there is a spike coming up, or there's going to be a period of lull, and then you balance that with something else. But in an online course, there is no. I mean, you do have students in the course, but it's not like an on-campus interaction. So I would say it took a while to adapt to that. And I would actually recommend, I mean, if you're taking this course, be mindful of that there are going to be spikes in difficulty, and you kind of have to adapt in the middle. And if you do, let's say, let a week or so slide without adapting to it, it could catch up. The next 3-4 weeks could get progressively more challenging. So that's something that took me by surprise. But I think once
Yeah.
you adapt to it, you get used to it. Yeah.
Yeah, that's great. And I'm glad that you mentioned that, because it is an area, it's a learning curve when you're dealing with balancing multiple things at once with it when it comes to coursework, your job, family commitments. And when those spikes happen, it's time to gear down and really manage your time, which I think is another muscle that a lot of our students really have to flex with this program in particular. So I appreciate you sharing that. And yeah, I agree with you. It's funny. I heard a great saying the other day where online is convenient, but convenient doesn't mean easier. And I think this offers the flexibility to be able to do this while working, but time management is a huge skill that a lot of our students that we followed up with they need to build and be prepared for with the coursework. So I appreciate that. All right, let's go to the next slide. Karthik, let's start with you this time, and we'll kind of like flip flop. What was your experience like with the instructors? You kind of alluded to this, but also just the course material itself. Like, how did that work typically for you?
I think the instructors are great. We actually got a mix of instructors. For example, in our first course, there were actually like the one main professor, Dr. Kara, and we actually had 3 TAs who were alternating. So we managed to hear like different perspectives. Like is not just like going through the course, but they also had their own opinions of, machine learning, the direction of, neural networks, like the history of it and what they think are important things. And one person's opinion is slightly different from the other. So that's actually really good, because then you start listening you start understanding things from multiple perspectives. In terms of, I think the second, the deep learning course was also very similar.
Gotcha. Yeah, that's great. Thanks for sharing that. That's good perspective there. Jem, what about you?
Let's see. The first part is with the instructors. Yeah, I mean, the instructors are great. And I'm on the same, I think, classes with Karthik. And the first semester, which was last spring, Dr. Kara went through going into the theory was, important part of the first class, because that's the fundamentals part, and you do want to understand the theory behind it. And most of the homework assignments, I think, were actually from his own research material. So that's, like, it's not classifying if the images are cats. That's like the typical thing. We were actually, the homework assignments were engineering problems, and like, for example, one of them is, you design a column profile with voids in the middle, and the whole idea is to predict if that, and we did that same example in all in throughout the entire class. So different machine learning techniques, we applied the same problem to a different using a different technique, just to be able to see which models actually work well and which ones don't. That also is a useful, like, compare and contrast as you build an intuition of which models that are useful in your study. So in that regard, I think the class was very, very well structured. Or like our last week's example was also, I thought I would never do something like this, which is basically given a molecule, what is its solvability? You can have billions of different molecules, and being able to use machine learning using neural networks to be able to actually predict that. I thought it was really cool. So where I was going with this is the classes are not basically cookie cutter classes. The professors actually put in their own experience into the class. So that was very, very valuable. And also, as Karthik was saying, that the assignments can get tough, and you do have to do a little bit of your own home, study, find materials, start things early, so you are able to actually catch the TAs, be able to ask the questions, to be able to complete your assignments on time. So it's not a walk in the park. So I should say that.
Yeah, thanks for sharing that. And you know, uh, going back to just student stories of folks that we've also worked with that have taken this program, that seems to be the consensus across the board, that when you sign up for a graduate certificate with CMU, the rigor will come, but hopefully that yields getting more out of it. So it's been a good give and take situation with that. Yeah, I appreciate that. That's great. Both of your perspectives were fantastic for that question. Let's go to the next one. This one's a good one, where, like, this goes kind of past the outskirts of the actual course. And so what have you been able to apply what you've learned in the program to your current role or other areas professionally? And Jem, we can start with you again to kick us off.
The first class is really learning all the fundamentals, just getting you prepped to be able to do actual, professional work. And the other areas that I could apply for the company that I work, we do have a lot of the company's sponsored research, and there are all the network related use cases that I could do. I will be seeking funding to be able to do those types of projects when this class's workload is over. You cannot do one of those and this at the same time. So
one step at a time.
yeah,
One step at a time.
Yeah, there you go.
Well, thanks for sharing that. That's great. Karthik, what about you? Anything you've been able to apply as you've been going through the program?
Yeah, this has actually been pretty interesting. I think there is actually quite a way to go for me in terms of learning from this program and maybe even what comes after to really start getting into like the depths of what I can apply. But I've seen two differences. The first one is I can actually understand a little bit more, even in my current role. Like I said, I work in the CFD, CAE, let's say FEM, EDA, that space, and there's a lot of focus on neural networks, AI, machine learning, and specifically physics-informed neural networks in my space. I think whereas earlier I was more of a bystander in those conversations, I felt like now I think I'm able to participate a little more. I actually understand what's going on. Like when there's a new development, I kind of can see, okay, this is what happened. For example, if my product has a new feature, I can understand, hey, you know what, this is what they built, right? So at the crux of it, and that's what is being called as a neural network based feature or an AI feature today. So that part is actually been quite useful. Sorry. Yeah, I've also been able to apply some aspect of it very recently. I think purely for learning purposes, I just built a neural network from for predicting let's say the outcome of a conduction problem using some synthetic data I built using simulations. I wouldn't say I built something significant with it. It's not a massively challenging thing to build, but it helped me understand, okay, you know what, this is even possible using data I used to create on a regular basis. Now I can actually do something else with it apart from just predicting temperature on top of a package, for example, right? Yeah, but I think the main thing I would say is going back to what I said earlier, there are so many new things that come now in the CAE space, a lot of focus on physics informed neural networks. I think even recently there was a conversation about PINNs. This course, for example, doesn't cover physics informed neural networks, but because we cover neural networks quite in depth, I was then able to go read up about PINNs and come back and say, you know what, this is what, we can do here. I don't think I would have been able to have that conversation from my end before I took this course. So that way it's been really helpful.
That's great. Thanks for sharing that. And I think some of the stuff you mentioned you worked on that you weren't too impressed with yourself about, I think you got a leg up on the rest of the majority of the population. So I think I'm impressed with it. I don't know if I could get that far as you did with building those things. So that's impressive to me. Yeah, thanks for sharing that, Karthik. That's awesome. And I think we have one more slide before the last, and this is the big question. We get this a lot, especially for some of our students that might be in the session right now that have maybe even been admitted and they're going to be starting this spring. Karthik, you can kick us off again. What do you wish you would have known before starting the program?
Definitely more Python. More Python always helps. Whatever little Python I knew, I mean, it was good enough for me to get started, and I managed to scale that knowledge up throughout the course. But I would say before you take the course, if you can spend a few hours, maybe ideally a few days, just take a Python course. I think CMU offers a free one. That's really going to help. I think that's the biggest thing that I wish I had known a little more before starting the program. Apart from that, I think, yeah, I think going back to some of the things I said over the assignments, there are lulls and there are spikes as well. So I wish I had known about some of the spikes before, but I think that's something you just get to adapt
Right.
once you start the course.
Excellent. Thanks for sharing that. Jem, what about you?
Well, I think I'm just going to repeat what Karthik said. I've early in my career, I did program mostly in C or C++. So Python is like is a different animal. You can do so much with it, and you follow the online classes, and it's like voodoo magic. It's amazing with a single line of code you can do so much with it. But to be able to effectively use it, you really need to learn Python quite well. And some of the packages, like the NumPy, is the main package that we use in the classes for doing the homework problems and use industry. So it's a really valuable skill to learn how to use NumPy well. So that's it. Yeah, I wish I had a little bit more time up front to become more proficient in Python instead of trying to learn it on the fly. And the second thing that I would mention is to be familiar with different programming environments. because typically Jupyter Notebook is used, but it took me a while to sort of say, okay, fine, I'm just going to go Google Colab. And it takes a little bit more effort to set it up properly, but once you do, then your life becomes easier. So getting that stuff out of the way, because when you're learning new things, and if you're also struggling with some of the like logistical things that I would say, like the programming and as well as your development environment, then it becomes frustrating. So get those out of the way before you actually start the course.
Excellent. Thanks, Jen. That's great insight there. And yeah, well, thank you both for answering those questions. Those were some of the big ones that we have a lot of curiosity around. So all of your information shed a lot more light on those questions, which we appreciate. And we will be going to the Q&A soon. I just wanted to take a minute for everyone to see this slide. If you haven't already been in touch with our program specialist, Marlene, this is going to be her contact and her direct email that you can get in touch with her about. Again, Marlene is great where she can talk more in depth about some of the program details that you might be still curious about. If you're interested in applying, we can help you step by step on how to get an application together and get you a decision. So ultimately, we'll be following up with each and every one of you after this session just to make sure all of your questions are answered and we can support you as best we can. But without further ado, for some of the Q&A, I actually wanted to start. You both mentioned, in that last slide, just some of the programming that you wish you had some more prep time for before starting the program. We actually had a really great question from someone on about the interactive learning opportunities in the program. So when you're going through your self-paced coursework, is there a place where you can practice with some of those programming languages on certain assignments, and how did that work? If that was something that you both went through.
Like for every week's material, there's typically an example code that's provided. So like there's one problem and all the code is available for that. So you can sort of go through that and try to understand it before they throw you your assignment, which is typically a little bit more hard, additional. And the classes are made out of two main lectures during the week. One of them is the professor goes through the theory and he like just covers the material. And the second one is more recitation, which is where the TA goes through the material, but then also goes through that example coding example that I mentioned a little bit earlier. So there you can actually ask questions about why is it done this way or that way. And between having that example problem sets going through with it with the TA over it is where you sort of learn the programming aspects of it.
Gotcha. That's helpful. Anything to add there, Karthik?
Yeah, I want to say all assignments need programming. There is no non-programming assignment, so you do have to finish all your assignments with some pieces of Python code. There are some things to help you, like Cem was saying. There are example recitations, I can't spell it out for some reason, but there are examples that of similar code that might be shared for some of these assignments that can give you an idea of the structure you need to follow. Sometimes there isn't, so you have to figure that out yourself, right? So, but all the assignments are coding assignments, and the interactivity, I would say that because we don't use .py, we use .py and B. So these are Python notebooks. They sit in Jupyter. You don't execute the whole code in one go. You execute blocks of it. So you are able to see throughout, the assignment, are you hitting those blocks of code successfully, and then you debug that and then you move on to the next step, right? So that way we don't just like run the whole .py in Spider or something. We use Jupyter Notebook or Colab, and I think that's a little more interactive than just submitting your whole script without
Right.
Yeah.
Yep.
Yeah, that's great. We did have a question about, I do want to touch on the question we got about the math background. So we talked about getting ready for the program as far as programming languages are concerned. Is there anything math-wise that students should perhaps prep in that would be helpful from both of your perspectives? Or I guess brushed up.
Yeah, if I may, I would say, first of all, I mean, just to understand the concepts, knowing, if you remember 20% of the calculus class that you took would probably be sufficient. The whole conceptually of what a derivative means, and what does a zero slope mean to be able to do like calculating the the optimal points for your data set. So that's pretty much the extent of it. It's not like you're going to have very, very complicated functions to take the derivative of. That's not really the case. And also just you know matrix arithmetic would you should know what the about matrix arithmetic, how to multiply, add, take inverse of matrices. Of course, you're going to have the NumPy do it for you, but you still have to be able to set up the matrices that you're going to be um, operating on.
Yeah, that's great. Karthik, anything you want to add there again?
Yeah, very similar to what Jem said. Basic linear algebra, nothing too fancy. Basic linear algebra plus some brushing up of derivatives, gradients, those topics. They actually give you, I think CMU actually gives you a primer or some kind of reading material on the basics of linear algebra, and even I think there's differential calculus also. Before you start the course, I think they give it to you maybe a month and a half. I would definitely recommend spending some time on that because that helps you brush up whatever you need to remember before you start the course.
Gotcha. Yeah, that's helpful. Thanks, Karthik. I really appreciate that. And we did have another question just about full-fledged master's programs. So our team directly doesn't represent any of the master's degree programs, but there are certainly a lot of degree programs out there underneath the CMU umbrella. So if you're ever curious about getting more information on that, we can help lead the way for that. But again, our graduate level certificates have been a huge advantage for everyone in our programs because, like I said before, most people are working and they're balancing other commitments. With the degree programs, those are much more stringent as far as being able to find balance outside of academia. So I would say that's the only thing that I would give advice on is if you're really looking for something that's going to allow you to balance multiple things in one time and still get that set of competencies that you're looking for, that's what the certificates were crafted for. So hopefully that helps answer your question there. And Karthik, I saw that you already were able to answer just about what your level of Python knowledge was before starting. So appreciate you answering that. I don't know if everyone is able to see that, but do you want to kind of just tell us audio wise what that looked like for you?
Yeah, I think the question was what was my level of Python understanding before starting, and my answer was somewhere between beginner to intermediate. For example, I would use Python mostly for automation tasks, so understood basic syntax, how to use loops. I would say even like things like arrays and lists and those concepts in Python, but I didn't have a lot of experience using libraries like NumPy, doing linear algebra operations with NumPy. So those things I didn't really use Python for before taking the course. So that's why I said somewhere between beginner and intermediate.
Got it. Thanks for sharing that. Yeah, I don't know, Jem, do you want to, just from your perspective in taking the program, someone with plenty of years of experience in the financial industry, mainly software programming, how this could be a good fit. And like I mentioned before, if you're really trying to resolve what is going to be the best pathway, that's what my team's here for. So when we follow up with you, to schedule a call with us and we'll talk you through all of the details to make sure, it's going to be a right fit. But Jem or Karthik, I'm not sure if you have anything to add to that particular question.
I would love to be able to develop a killer model that predicts the stock prices, right?
Right.
But
Yes.
I mean, it's all numbers at the end of the day. So and the finance sector is also like a lot of number crunching and getting an insight on what the data represents, and then being able to see patterns that humans cannot see through the traditional methods. That's where the machine learning actually would bring value. So yeah, I think
Right.
the the material applies. This class is not specifically like, from beginning to the end, going over a lot of finance or investments use cases, but the methods apply.
Great. It looks like we had another question. What about this course equipping you to know how to optimize an algorithm for efficient computation? Is that something that's that you all typically go through in the coursework here?
I mean, if I may, sorry, I'm jumping. I would say not a whole lot, because we're really using, some of the, well, we use PyTorch for running most of the available libraries, and PyTorch covers everything that you can think of that is developed within the machine learning world today. Of course, you do want to optimize for being able to run your training sets at a shortest amount of time, or avoiding unnecessary computations. Like, last week's example, for example, do this, but don't use for loops, simply because for loops take. So there are things, practical things like that, but it's not like, you take a known algorithm and then you rewrite it, refactor it so that it actually uses half the computational power. So it's not for that.
Gotcha. Anything to add there, Karthik?
I mean, yeah, exactly what Cem said. This course is, I mean, yeah, we have some direction sometimes to produce more efficient code for some of the assignments, let's say. But the idea is to here actually come up with the algorithms to solve the problem. The focus is not really to optimize existing algorithms, I would say. So yeah, yeah, basically what Cem said.
Right. Excellent. Okay, thank you. Any other questions? We're almost getting to time. Again, appreciate everybody, as well as you, Cem and Karthik, of joining us tonight. This was great. Shed a lot of light on the program, and I'm sure everyone here took away a lot of great information, so appreciate that. All right. Well, everyone have a great evening, and thank you again for joining us.
Thank you.